Hello, 8th grade. So the next part of geometry that we're going to talk about are polygons and angles. So I'm going to break this into two videos. Your first video is going to be on the interior angle sum of a polygon, and video 2 is on exterior angles of a polygon. So this is video 1, interior angle sum of a polygon. So you guys know that a polygon is a shape. That's a closed figure. It's two-dimensional, and it is created by line segments that are closed. Okay, so for example, a triangle, quadrilateral, pentagon, hexagon, octagon. Okay, those are examples of polygons. So we're going to talk more about that later. Okay, so since we're talking about angle sums, I've gave you an example in words and symbols. So in words, the sum of the measures of the interior angles of a polygon is n-2 times 180, where n represents the number of sides. So that's just saying that that's the formula, and we can use that to help us find the sum of the interior angles of a polygon. So if we were to write that in symbols, I have S equals the quantity n-2 equals 180. And n is going to represent the number of sides of that polygon. Okay? All right, so two things here to think about. You can use the sum of the angle measures of a triangle to find the sum of the interior angle measures of various polygons. A polygon that is equilateral, which means all sides are the same length, and equiangular, which means that all angles have the same measure, that is called a regular polygon, okay? So I made a poster on polygons, so I'm going to post that on Live Grades. I will send it to you all, and I will post it on the class story on Class Dojo. So you guys can look at that information as a reminder, as a graphic organizer, because if we were in class, we would have created something like this at the beginning of this lesson. Okay, so now we're going to look at some examples of finding the sum of interior angles. So the first shape that we're going to look at is a hexagon. So we know that a hexagon has 6 sides. Okay, so we are going to use the formula S, and that capital S means sum, equals n-2 times 180. Okay. All right, so since a hexagon has 6 sides, this n represents the number of sides. So I'm going to replace that n with 6. So I'm going to have S equals 6 minus 2 times 180. Okay. All right, so I know that 6 minus 2 is 4. So I'm going to have to do 4 times 180, and 4 times 180 is 720 degrees. So that means that the sum of the interior angles of a hexagon is 720 degrees. So that would mean if I had a hexagon, I had a 6-sided figure, all of the angles and all of the sides were the same, that if I added the sum, if I added all of those angles together, the sum would be 720 degrees, okay? All right, so next let's look at an octagon. So an octagon has 8 sides, so we're gonna use this formula again. The sum is equal to the number of sides minus 2 times 180. And the 180 is because if you refer to that chart, you are able to see that in these shapes, we can create triangles, okay? And if we take the number of sides and minus 2, so if I have an octagon, 8 minus 2 is 6. So within an octagon, I can create 6 triangles, okay? And then 6 times 180 is 1080. So that means that the sum of the interior angles of an octagon is 1080. Okay. All right, number 3, this example. A 15 gone. Okay, so there is a name for a 15-sided figure. So you could say the name, or you can just call it a 15-gon. Either one of those is acceptable in math, especially when you get to shapes that have several sides, okay? So if this means it has 15 sides. So I'm going to use the formula. 15 minus 2 times 180. Well, 15 minus 2 is 13. So I'm going to do 13 times 180, which is 2,340. So if I have a 15-sided figure, all of the sides and all of the angles are the same, then that means it is going to measure the sum of the angles on the inside is 2,340. Okay, so now what we're going to do is we're going to take those sum of those interior angles, and we're going to use that information to help us find the measure of one of the interior angles. Okay, so I have an octagon. We know that an octagon has 8 sides. Okay, so we would use the formula S equals n minus 2 times 180. Remember that n is representing the number of sides. So I'm going to find the sum of the interior angles first. So I'm going to do S equals 8 minus 2 times 180. So S is going to be equal to 6 times 180. And we already did this one, so we know that 6 times 180 is, whoops, I shouldn't have, is equal to 1,080, okay? Now, this is all of the angles. Well, how many angles does an octagon have? An octagon has 8 angles, okay? So we would take this number and divide it by 8 because we want to find the measure of each angle. So by dividing it by 8, that will give us the measure of each angle. So 1,080 divided by 8 is going to equal 135 degrees. So that means each angle measures 135 degrees. So what we can do for this, if you're finding the measure of one of the angles, we can take this formula and we're going to divide by the number of sides that we have. So we're going to divide by n. Okay, so let's use this to help us with number 2 or number 5. Okay, we have a heptagon. A heptagon has 7 sides. Okay, so a heptagon has 7 sides. So we're going to use this formula. S equals the number of sides, which is 7, minus 2 times 180 divided by the number of sides, which is 7. Okay, so by multiplying this, or by doing this, the top, what's on the top, that tells us the sum of all of the angles, and then dividing it by 7 tells me the sum of one of the angles. Okay, so the heptagon has 7 sides. Okay, so I'm going to do 7 minus 2, which is 5. So I'm going to have 5 times 180 divided by 7. Well, 5 times 180 is 900, and 900 divided by 7 is what I need to do. So you will find out that when you do 900 divided by 7, you get a decimal, but we're going to round to the nearest tenth. So if we round to the nearest tenth, we get 128.6 degrees. Okay. So we take the number of sides, we minus 2. We take that, multiply it by 180, then divide by the number of sides the shape has, because that's how many angles it has, and that will tell us the measure of one angle. Okay? All right, and then I have a 20-gon. So again, this figure has 20 sides. So we're going to use our formula. S equals 20 minus 2 times 180 divided by 20. Okay, so 20 minus 2 is 18, so I have 18 times 180. divided by 20. Okay, so 18 times 180 is 3,240, and I'm going to divide that by 20. And 3,240 divided by 20 is 162 degrees. So the sum, or the measure of one angle in a 20-gon is 162 degrees. So what we are going to do for this, we are going to remember that the formula for calculating the sum of the interior angles is S equals the quantity n minus 2 times 180. And if you're finding the measure, this should be your. If you're finding the measure of one angle, you're going to divide the sum of the angles by the number of sides. So have fun with polygons and angles.